Let us find the factorization of x raised to q minus 1 for g of q. So for finding this factorization, we will take first the Gauss field 2. So Gauss field 2 has the elements 0 and 1. Non-zero elements are 1 here, and q is equal to 2. Q minus 1 is 1. So non-zero element raised to q minus 1. 1 raised to q minus 1 is 1. So x raised to q minus 1, that means x raised to q minus 1 is x minus 1. And 1 raised to q minus 1, suppose if you put here 1 raised to q minus 1 is also 1, so 1 is the factor of x minus 1. That means non-zero element raised to q minus 1 is 1, and x raised to q minus 1 minus 1 has the factor 1. Then let us take Gauss field 3. So it has elements 0, 1, 2. Non-zero elements are 1 and 2. Q is equal to 3. Q minus 1 is equal to 2. X raised to q minus 1 is equal to x square minus 1, because q minus 1 is equal to 2. So let us find the q minus 1 powers of non-zero elements. So non-zero elements are 1 and 2. So q minus 1 is 2. So 1 square, 1 raised to 1 square is equal to 1 mod 3, because it is Gauss field 3. So how you are going to do this? 1 mod 3 means 1 divided by 3. What is the remainder? Remainder is 1. So 2 square, non-zero element raised to q minus 1, 2 square is equal to 4. 4 mod 3, because it is Gauss field 3. So if you divide 4 by 3 and take the remainder, it will be 1. So here also we can say that non-zero elements element raised to q minus 1. Non-zero elements are 1 and 2 raised to q minus 1 is equal to 1. Then that means x square minus 1. So if you put x is equal to 1, 1, then 1 square is equal to 1. Then if you put x is equal to 2, then 2 square is equal to 1. So 1 and 2 are the factors of x square minus 1. So we can write x square minus 1 as x minus 1, x minus 2. That means x raised to q minus 1, because square is q minus 1 is equal to x minus 1 into x minus 2. That means x raised to q minus 1 is equal to x minus non-zero element, x minus another non-zero element. So let us check it for Gauss field 5. So for Gauss field 5, the elements are 0, 1, 2, 3, 4. Non-zero elements are 1, 2, 3, 4. Q is equal to 5. Q is equal to 5. Then q minus 1 equal to 4. Then x raised to q minus 1 is equal to x raised to 4 minus 1. So let us find the q minus 1 powers of non-zero elements of Gauss field 5. So 1 raised to 4 is equal to 1 mod 5. So that is equal to 1. If you divide 1 by 5 and take the remainder, it will be 1. Then 2 raised to 4, that is equal to 16 mod 5. 16 by 5, remainder is 1. 3 raised to 4, 81 by mod 5, that is also 1. 4 raised to 4, 256 mod 5, that is also 1. That means non-zero elements q minus 1 power will be 1. So if you put here 1, then it will be the factor of x raised to 4 minus 1. Then 2, it will be also the factor of x raised to 4 minus 1, because 2 raised to 4 is equal to 1. 3 raised to 4 is also equal to 1. So that is also factor of x raised to 4 minus 1. 4 raised to 4 is also equal to 1. So 1, 2, 3, 4 are the factors of x raised to 4 minus 1. So we have written here that x raised to 4 minus 1 is equal to x minus 1, x minus 2, x minus 3, x minus 4. So let us check this funda with the Gauss field 7. So Gauss field 7 has the elements 0, 1, 2, 3, 4, 5, 6. Non-zero elements are 1, 2, 3, 4, 5, 6. Q is equal to 7. Q minus 1 equal to 6. X raised to q minus 1 is equal to x raised to 6 minus 1. So let us find q minus 1 powers of non-zero elements of Gauss field 7. So 1 raised to q minus 1 is 6. So 1 raised to 6 is equal to 1 mod 7, that is equal to 1. 2 raised to 6 is equal to 64 mod 7, because it is Gauss field 7. So 64 divided by 7 is 9 sevens are 63, so remainder is 1. Then 3 raised to 6, 729 mod 7, that means 729 divided by 7, remainder is 1. Then 4 raised to 6, 4096 mod 7, that is equal to 1. 5 raised to 6, 15625 mod 7, 1. 6 raised to 6, 46656 mod 7, that is also equal to 1. That means if you put in this equation 1, 2, x is equal to 1, 2, 3, 4, 5, 6, then x raised to 6 minus 1 is equal to 0. That means 1, 2, 3, 4, 5, 6 are the factors of x raised to 6 minus 1. So we can write x raised to 6 minus 1 as x minus 1, x minus 2, x minus 3, x minus 4, x minus 5. So now we can come to one conclusion about factorization of x raised to q minus 1. So conclusion is that for GFQ, if it has beta 1, beta 2, beta 3, beta q minus 1, non-zero elements, then beta 1 raised to q minus 1 is equal to 1, beta 2 raised to q minus 1 is equal to 1, beta 3 raised to q minus 1 is equal to 1, beta q minus 1 raised to q minus 1 is equal to 1, and x raised to q minus 1 is equal to x minus beta 1, x minus beta 2, x minus beta 3, x minus beta q minus 1. So same here we have seen for Gauss field 7, non-zero elements 1, 2, 3, 4, 5, 6, that is beta 1, beta 2, beta 3, beta 4, beta 5, beta 6. So those raised to q minus 1, those raised to 6 is equal to 1. So beta 1 and all raised to q minus 1 is equal to 1. And we have also seen here that x raised to 6, that means x raised to q minus 1 is equal to x minus beta 1, x minus 2, 3, 4, that is x minus beta 1, beta 2, beta 3, beta 4, beta 5, beta 6. So this is very important equation, or this is very important conclusion. I tried it to make you convince with three by taking the examples from Gauss field 2, 3, 5 and 7. So once again we will see to the conclusion that if for a Gauss field Q, if it has beta 1, beta 2, beta 3, beta q minus 1 as non-zero elements, then beta 1 raised to q minus 1 is equal to 1. That means every non-zero element raised to q minus 1 is equal to 1, and x raised to q minus 1 has the factors beta 1, all the non-zero elements of that field are the factors of x raised to q minus 1 minus 1.